Hi there, welcome to my channel. In this video, I'm going to discuss about the solution for merging k sorted linked list. Let's look at the problem description. We are given an array of k linked lists and each linked list is sorted in ascending order, and we have to merge all the linked lists into one sorted linked list and we have to return it. Let's take a look at the example 1. Here the list is an array of 3 linked lists. So first linked list has 1, 4, 5, second one has 1, 3, 4, and third one 2, 6. After merging, we have 1, 1, 2, 3, 4, 4, 5, 6 in an ascending order. So in the case of example 2, we have an empty array. For that, the output will be empty linked list. And in the case of example 3, we have a one entry in the array, but that is an empty list. In this case also, output is empty list. The constraints for this problem are the k is equal to the length of the input array. Value of k is ranging from 0 to 10,000. And length of the individual lists is ranging from 0 to 500. And the value of the individual elements in the linked list will be minus 10,000 to 10,000. Okay. And all the nodes in the lists are in ascending order. Sum of the length of all the linked lists will not exceed 10,000. Let's look at the approach to solve this problem. We are given an array with 4 linked lists and each lists are in ascending order. And after merging, we get 1, 2, 3, 4, 5, 6, 8, 10. The simplest approach to solve this problem is merge the rest of the lists to the first linked list. First merge the list 1 to list 0, then list 2 to list 0, and list 3 to list 0. In this approach, the number of link manipulation will be very high, especially as this list gets built up, then we'll have to compare too many elements. Another approach we can use is divide and conquer approach. Basically, we can divide the input into a smaller subproblems and solve the smaller problems and then merge the solution of those problems back to generate solution for the original problem. So in this case, we can divide the input lists into a smaller sets and merge those smaller sets first, and then the results of those merge will be again merged back. Finally, we get the complete sorted list. For example, in this case, first we divide this problem into a smaller problem by having 2 lists in each subproblem. So first we merge these 2 lists. Next we merge these 2 lists. We get this list by merging the lists at index 0 and 1. And we get this list by merging lists at index 2 and 3. Okay. The next step will be merge these 2 lists in turn to generate the final sorted. After merging these 2 lists, we get the final list. We increase the distance, double the distance, because earlier the distance between these two are 1. Now the distance between the lists to be merged will be double. Okay, so now list 0 and 2 will be merged. So when we have a distance 2, these 2 lists will be merged. Basically the list 2 will be merged into list 0. Then finally we get sorted list. The number of comparison will be less than the previous approach. That's what I have written here. Basically we can use the divide and conquer approach. First we initialize the distance between the lists to be paired as 1. Okay, and then if the distance is less than the number of lists in the input, we traverse the lists in the input and pair the lists that are a current distance apart and then merge those 2 lists. Otherwise we have to return the linked list at index 0 in the input array. So basically we have to repeat this process by doubling the distance each time. Finally, the list 0 will contain a linked list in sorted order. Let's look at the flowchart. The input for this procedure is an array of lists. First we initialize the distance to 1 and initialize the count variable with the number of elements in the given array. First we check whether the count is equal to 0. In that case, the output will be empty linked list. Okay. Otherwise, we check whether the distance is less than the count. If it is true, then we initialize index to 0 and then we check whether the index I is less than count minus distance. If that is true, then we initialize the first index with I and the second index with I plus the current distance. Okay. Then we merge the linked list present in these two indexes in the input array and assign the result to an entry at index first IDX. Okay. Next, we have to find the next pair. Okay. For that, we have to update the index I by adding the double the distance plus the current value. We locate the next pair by updating the value of I by I plus 2 times the distance. Okay. So we keep locating the next pair. We merge those linked lists. Once the index is greater than count minus distance, then we come out of the inner loop and then double the distance. Okay. Basically, in each outer loop iteration, we reduce the number of lists to be merged. If the distance is greater than or equal to count, then we come out of the outer loop and then return the linked list present at index 0 in the input array, and finally return that list head as the output. Let's move on to coding. First, I initialize the count variable with the length of the input array, and then I initialize the distance to 1. Then I check whether the count is equal to 0. If it is 0, then I return null as the output. Then I write the for loop. This will run until the distance is greater than or equal to count. So in each iteration I double the distance. Next I write the inner for loop which merge two linked lists in each iteration. This for loop runs until I is less than count minus distance. And in each iteration the i's value will be updated by adding double the distance to the current value of I. Basically that is the location at which the second pair will be present. So in each iteration I compute the index of the first linked list which is I and index of the second linked list which is at first IDX plus the distance. Then I call the merge lists function which will merge the linked list present at first index and the second index. Then the result will be assigned to an entry at first IDX in the input list. And finally I return the linked list at index 0 in the input array. Next I am going to write the merge lists function. This takes the head of the first and second linked list and return the head of the merged list. First I initialize the head, tail and the node pointers. Then I write the for loop. This will run as long as first and the second pointers are not equal to null. Each iteration I compare the value of first and the second node. If first value is less than second, then I assign the first pointer to node and then update the first pointer. Else I assign the second pointer to node and update the second pointer to point to the next node. Then I update the next pointer of the node to null and then I check whether the tail is equal to null. In that case this is the first element in the linked list, so I update the head and the tail pointer to point to node. Otherwise I make the current node as the next node of the tail and then I update the tail pointer. Once we come out of the loop, either one of the list may be not equal to null. So if the first is not equal to null, then I check whether the tail is not equal to null. In that case I make the first pointer to be the next node of the tail. Else I make the first node as head of the linked list. If the second is not equal to null, then I check if the tail is not equal to null. In that case, I make the second node as the next node of the tail. Otherwise, I make the second as the head of the linked list. Then I finally return the head of the linked list. Next, I'm going to run the test cases. All the tests passed. Next, I'm going to submit this program. Cool, this program is accepted. Next, I'm going to do the code walkthrough with sample input. We are given the input array with 4 linked lists, and the expected output is 1, 2, 3, 4, 5, 6, 8, 10. So first we initialize the count variable and the distance variable. So the count is initialized with the number of elements in the input array, and distance will be initialized with 1. Basically, we pair the adjacent linked lists. So first we check whether the count is equal to 0. If that is true, we return null as the output. Otherwise, we compare the distance with the count. If the distance is less than the count, then we enter the for loop body. So in the iteration 0 of the outer loop, the distance is 1 and the index is equal to 0. This for loop will run until the index I reaches count minus distance. In the iteration 0, we initialize the first idx to the value of I, which is 0. Then the second idx will be computed by adding distance with the first idx. So in this case, the distance is 1, so 0 plus 1 is 1. Okay. Next, we merge the linked list at index 0 and the linked list at index 1 by calling merge list function. Okay. So once the merge is done, we update the linked list at index first idx. So the first idx will have the merged linked list. Okay. So now it has 1, 3, 4, 5. Then the index I will be updated by adding twice the distance to the current value of I. Okay, so that it points to the next pair. Okay, so in this case, I is 0. 0 plus 2 times distance is 2 times 1. So the index, the I value of I is equal to 2. Okay, so now we assign the current value, the I, to the first idx variable, and we compute the second index by adding distance to the first idx. The first idx is equal to 2 and the distance is 1. So the second idx is 3. So basically we have to merge the linked list at index 2 and at index 3. So after merging, we get a linked list 2, 6, 8, 10. Okay. So once this is done, then we update the value of I. Now 2 plus 2, 4, which is equal to count, which is greater than the count minus distance. So we break out of this inner loop. Then in the outer loop, we double the distance. Okay. So initially it was 1. When the inner loop exits, we double the distance to. So now the distance will be 2. Again, we process the input array with the distance 2. So in the iteration 0, the value is 0 and we compute the first idx by assigning the value of I. So first idx is 0 and then compute the second idx by adding distance to the first idx. So in the now the distance is 2. So 0 plus 2, 2. Second linked list is picked from the index 2. Okay. So the linked list at index 0 and the linked list at index 2 will be merged by calling merge list function. So once the merge is done, the return value will be assigned to an entry at index first idx. So we have the head of the sorted linked list at index 0. Then we update the value of I by adding 2 times distance to the current value of I. So the 2 times distance will be 4 plus 0, 4. So that is greater than or equal to the count minus distance. So we break out of this loop and then we double the distance now. So the distance will become 4. 2 times 2, 4. So when we come here, this condition false. So we break out of the outer loop as well. And then we finally return the linked list at index 0, which has the sorted linked list 1, 2, 3, 4, 5, 6, 8, 10. And that is an expected output. Next, I'm going to do the time and space complexity analysis for this solution. The time complexity for this procedure is order of n times log k, where k is the number of lists in the input array and n is the total number of nodes in the input. So let's take a look at this case. Input list has 4 elements and each is pointing to a linked list of size 2. Okay, so totally 8 elements here. And the expected output is in a linked list in sorted order, which is 1, 2, 3, 4, 5, 6, 7, 8. So for this input, the outer loop performs 2 iterations. So to begin with, the distance will be 1. In the second iteration, the distance will be 2. And then in the next iteration, this condition will be false. The outer for loop performs 2 iterations. So when the distance is equal to 1, let's see how many nodes are processed by the inner loop in each iteration. Okay. For this input, in the iteration 0, we process the linked list at index 0 and at index 1. Okay. So totally 4 elements we merge. Okay. And in the second iteration, we merge the linked list at index 2 and at index 3. Okay. So when we merge totally 4 nodes. And when the distance is equal to 2, we merge 2 linked lists. One is at index 0, which has these 2 lists merged, and one is at index 2, which has these 2 lists merged. Okay. So totally we merge linked list 1 with 4 elements and the linked list 2 with 4 elements. So totally we merge 8 elements in the iteration 0 when the distance is 2. So if you look at it, the inner for loop merge 8 nodes. Here also it merge 8 nodes, which is equal to the total number of nodes in the input. Okay. So how many times this outer loop performs? 2 times. So for 4 lists with 8 elements in total, this procedure merge 8 times 2 number of nodes, where 8 is the total number of nodes in the input and n is the log 4 base 2, which is 2. Okay. So if there are k lists with n element, then the total number of nodes merged will be n times log k. So that is the time complexity of this procedure. Space complexity is order of 1 because we are not allocating any additional space or creating any temporary linked list. We simply perform link manipulations in these for loops. So the space complexity is order of 1. Thanks for watching this video. Have a great day.